which is also, you can see, plays a very, very pivotal role. And I feel the Department of Civil Engineering at PDU actually focusing on many aspects in their curriculum. And in fact, we have actually introduced this year a digital transformation in civil engineering. At the same time, we have also focused on safe and resilient structures and the sustainable structures, where we actually able to talk about the precast structures, pre-engineered buildings. And I think these are all, you can say, the buzzwords probably for the future civil engineer. So I feel this particular workshop is quite relevant. uh, I personally would like to congratulate all the coordinators who have actually taken the effort to organize this, and I wish this particular initiative will continue in future also. And at the same time, the participants who have actually came through, I think they may have a very, very good day, very, very knowledge exchange, very good knowledge exchange will going to happen. So thank you very much. It will be a very fruitful day. I mean, thank you.
Thank you very much, sir. Thank you very much, sir. So today, now we are going to start the first lecture series, that is given by P. Suryaprakash Garu. So before start the session, I'm going to introduce about P. Suryaprakash Garu. So P. Suryaprakash Garu is an eminent engineer and consultant and mentor who has made significant contribution in civil engineering. The Suryaprakash sir has obtained his bachelor degree from JIT Kakinada in year 1986, and he did his MS in structural from IIT Madras in 1990. Okay, after working for 5 years in a design field, in 1994 he established Satyavani Projects Consultant Private Limited, and he is also founder and mentor of SmartInfr-EST. He has wrote a book on design and implementation of communication tower, and he was member of the expert committee for categorization of seismic damages in structure, and he is also mentor for many BTech and MTech projects like under JNTU, NIT Warangal and IIT Madras. Suryaprakash sir has handled several prestigious projects during past 3 decades. Some of the projects he undertook includes affordable housing, buildings, residential, commercial, office and IT industrial structures, hospitals, hotels. In infrastructure, he has given contribution in developing the roads, bridges, metro rail, and runway. And he is also expert in the designing the transmission line towers and FM, microwave, cellular towers, and some of the prestigious clients with whom he worked is Minister of Defense, Tech Mahindra, GBK, GMR, and Ashoka. So with this brief introduction, I want to welcome Suryaprakash Garu to start this session. So sir, now I am making you a host. So please start the presentation. 1 minute.
Thank you, Pradeep, for a good introduction about me, good words. And thank you, Tejas ji, for giving me this opportunity to share some of my experiences in the infrastructure development. And today, fortunately, I got the opportunity to work, or rather, I have always chosen projects in wide spectrum in infrastructure. So I got the opportunity to involve in starting from buildings and infrastructure like communication towers, transmission towers, roads, bridges, and even some of the defense projects like runways. And so I gained some knowledge, and I would like to share that to mainly motivate the students and also share the knowledge with the faculty and other experienced people, whoever is here. So I'm just waiting for the.
Sir, I have made you as a. Now you can share the screen, sir. I have made
Yeah.
the changes. You can share the screen.
Make me the host so that I can
Yeah, you
share
can.
my presentation.
Now you can share this, please.
No, it's still not done. Only meeting. Yeah, got it. Thank you. Hope you're able to see my screen now.
Yes.
Okay. So, first of all, I congratulate Pandit Deen Dayal Energy University for organizing such a nice topic workshop, and I'm privileged to talk on this topic, which is very close to my heart. That is the role of structural engineer in infrastructure development. Primarily, I focus my talk for undergraduate engineering students and, of course, the academia. So this is the topic today. I hope all are ready, and students particularly, I request you to keep noting what I say and ask me questions towards the end. And also, I'm always available on my mail, Facebook, LinkedIn, and for any of your doubts, you can like our page, SmartInfr-EST. So through that also, I try to help students in planning their career and mentoring their career. So with these few words, the overview of my topic today is the introduction to the topic, and we briefly understand what is structure and who is a structural engineer. And can somebody accept? I am getting message. People are waiting in the waiting room. Other than me, can anybody accept, or should I do it?
We'll accept it. No need to do. We'll accept
Okay.
it.
Okay. Okay. Thank you. So structure. We briefly define what is a structure, who is a structural engineer, and what is the role of and responsibility of a structural engineer in infrastructure development. And I briefly share some of the projects that Satyavani Projects and Consultants Private Limited, for which I am the managing director and chief consultant. I'll share the experiences. So we are basically civil engineers. As we all know, the word civil engineer has been named after the military engineering has come. Otherwise, engineer was called Vastu Sastrajna in ancient Indian times, and master builders in European Roman times and all. And after that, the word engineer has come from the master builder. And once this military engineering started, the engineering that deals with civilians is called civil engineer. So we are all civil engineers. And in civil engineering, the department or people who deal with the structures are structural engineers. And we all deal with construction or constructed facilities. As we all know, any civilization needs constructed facilities. It all started with the housing need, because we have to cover from and protect ourselves from the nature's vagaries, like temperatures, lower or higher temperatures, rain, snow, all these things. So we need a house. That's how the primitive man has realized and started building houses. And now we are engineers. We are doing beautiful construction and generating constructed facilities. Started with the house, and now there are so many needs which we'll be sharing as we move forward, whether it is a working space or the convention centers, exhibition centers, and all are called constructed facilities. And the role of structural engineer is primarily to ensure the stability of the structure. Stability means it should be in equilibrium throughout its life, service life of the structure. And the serviceability, apart from stability, once we establish stability, the next most important thing is the serviceability. As if you are studying IS 456, you will understand what is the serviceable limits for deflections or deformations, and also the whether it is dampness or the facilities that are to be made to be functional. So that is the serviceability, whether it is plumbing, sanitary, or electrical, all depend on structures serviceability actually. So this is a brief introduction, and also we have to keep in mind the disasters as structural engineers. Any disaster can happen, like blast, fire, or flood, and earthquake. Earthquake, though, is a design load, sometimes it can be disaster. What happened in Gujarat, we all know. I was there in Gujarat after earthquake for a week to be working for the government to help arrive at the policy for deciding structures continuance and all that. That was a big experience for me. Gujarat taught me a big lesson, and also I was also consultant for government of Andhra Pradesh for hazard mitigation, which also I'll be sharing. That is cyclones. So we deal with cyclones, we deal with tsunami, we deal with earthquakes, we deal with flooding, all these things. So that is the beauty of a structural engineer. We understand all the loadings that we have to deal with. We understand the material that we can use, and we know the construction technologies, whether it is precast, now latest 3D printing, or the pre-engineering steel structures. So that's the beauty of structural engineering, and the pride of a structural engineer to know about how to make a structure live. So with this brief introduction, I'll start the overview. I'll start with introduction. Like we deal structures in housing, structures in transportation, structures in buildings, like convention centers, exhibition centers, auditorium, industrial buildings, power, which is a very essential thing, the power generation, transmission, distribution, and last utilization, last end user utilization. Next is the communication. If we are working today on this internet or this telephone, it is all the communication. And then irrigation. Irrigation is mainly for water supply for agriculture. That is a very, very important thing. We all know the food. So we deal with the roti, kapda, or makan. Kapda comes from cotton, agriculture, and industries, textile mills, which we design again, and then the garment manufacturing. All these we deal with roti, kapda, or makan. So this is the most important role of a structural engineer, and in general, civil engineer. So sports stadiums, we know every time Olympics happen, new type of structures we see, whether it is in China or Britain or now Tokyo. Unfortunately, Tokyo Olympics didn't happen. And tourism, entertainment, hospitality, leisure. We had the opportunities to work on leisure projects. And temples, the Indian heritage, we all know how beautifully temples are, and they're also structures. So it will be a good subject for us to study even those structures, how they are designed, how they are concentric actually. The theory of temples is from Sthapatya, which is part of Vastu, and so that is also good structural engineering to learn. And bridges, we deal with connecting two ends of a river or two separated facilities. Space structures, space, that is now, it is gaining importance. We are talking about hotels on Mars, communities on Mars, and so we have to also specialize in space structures, airports, ports, and railway stations or bus station, and skyscrapers. Now the high-rise construction is a norm of the day. You must have seen recently in Dubai, they are coming up with the longest cantilever structure. So we have to keep updating ourselves, and transmission towers for power transmission, radio high mass, that is FM and all that. So it's so many things. We can specialize in any of the areas. And as I informed, I had the opportunity to work in all these domains. So what is a structure? Let us understand structure. The role of a structure is to cover, to connect, to support, to protect, and to hold. So I'll not go into the details, but just remember these words, and anyone having any doubt about any of the terminology I'm using, you can ask me towards the end. And transfer the loads, isolate sometimes in earthquake criteria, and elevate overhead tanks like. And we should have any structure should deal with the loads, and we should also have the understanding of the materials, what kind of material, and we also have to keep in mind the possibility of a blast, dynamic loading, impact loading, and flooding, cyclone, etc. And earthquake resistance is a compulsory thing. Any structure that, particularly in India, we are highly earthquake prone, seismic zones are there, and we have to design. And elements and systems, structural elements we should understand, and structural systems we should have the idea. And ultimately, we deal with the forces in the members and deformations in the structure or structural elements. So we have to keep the deformations within the serviceable limits, and we have to design for the forces for the stress, allowable stresses, whether it is flexure, axial, or shear, and then strains, in-plane stress, in-plane strain, and all that. And we have types of structures of linear like beam, planar like slab, and spatial like domes and spatial structures, 3D spatial structures. So this is about a structure. And let us now get into the topic of today, that is what is infrastructure development. Basically, any infrastructure development is for the sake of economy. That is to give a comfortable and respectable living to the people, humanity, civilization, and citizens. And then economy will grow, GDP will grow with the investment in the infrastructure. So what is infrastructure? Infrastructure is basically transport systems, communication network, seaways, waste management, water for drinking, water for agriculture, electrical systems, that is power, education, health. So these are all the primary infrastructure areas. And again, the infrastructure can be categorized into two parts. One is the economic infrastructure, in which we deal with irrigation, that is for storage of water like reservoirs, dams, and all that, and distribution channels. And then power, we deal with generation, transmission, and distribution. Transportation, it's a huge subject, I'll share in the next slide. And communication, we have FM, radio, internet, TV, 4G, 5G, cellular nowadays. And social infrastructure. The social infrastructure is essential for any civilization. That is basically education, that is buildings of schools, colleges, institutions, and universities. Health services like hospitals. Yesterday we have seen in Mumbai, fire accident in the hospital. It keeps happening, but still people are very careless about following the fire safety norms. So it's very important as engineers for us to insist on following these safety norms which are defined in National Building Code. And sanitation, drainage, sewage treatment plants, and solid waste management now. And housing, for affordable housing for poor, economic weaker sections, and communities like middle class, upper middle class, and ultra rich also. We have to do, housing is required for anybody. And water supply, storage of water in the reservoirs, trunk mains, that is transmission of the water, treatment, water treatment, and water distribution. So these are all the areas in what we call infrastructure that we deal with as structural engineers. So let us go into the, because transportation is a huge area. We now know airports is a transportation. Now space transportation also is going to add actually. And defense, inland navigation. In defense also huge transportation will be there. So we designed the runways for Sukhois and all that, and inland navigation. Now it is being given high thrust because it's a green way of transporting. Use the water bodies and use the inland navigation, and rail, dedicated freight corridors, metro and bullet trains. Metro is for urban, and ports and harbors, highways, national highways, state highways, and district highways. And now the latest trend is expressways, elevated corridors for expressways without intersections. So urban transport, we have multimodal transport, metro trains, bus rapid transport, mass rapid transport, monorail, light rail transport. These are all the urban transport systems that are there. And fortunately in India, all these are happening now. So you can study any of these, specialize in any one event. And transit hubs is the next thing. Like what is happening is you have the intercity connectivity, interstate connectivity, national connectivity, and then we have the within the city connectivity. So you will have the transit hubs. People should be able to transit between these modes of transport. So these are all the things we deal with in transportation. Now structure, let us go into the details of structure. We should understand the material properties of the structural elements, that is Poisson's ratio, thermal coefficient of thermal expansion, elasticity, rigidity, modulus of rupture, specific gravity, toughness, hardness of the material, plasticity and ductility. So these are all the properties we should have the idea about material. And then section properties, the area of cross section, moment of inertia, section modulus, radius of gyration, all these we should understand and have the clear understanding of the concept. Next is the phenomenon of buckling, creep, sag, shrinkage. Sag happens for the tensile cables actually. And the natural frequency of the structure, time period of the structure, and the resilience of the structure, and the stiffness of the structure and structural elements, and the structural behavior, symmetry in the structure, and the boundary conditions. Like we have this hinge, fixed roller, and clamped boundary conditions. Are you able to hear to me? Yeah.
Yes, sir.
Yes, sir.
Okay, thank you. Because suddenly my screen has become plain. Okay. So boundary conditions, we should have as a structural engineer, we should have the understanding of what is hinge, what is roller, what is fixed condition, and what is the clamped condition. So these are all the things we should know about structure. So what are all the structures we deal with? So this is a metro. This is a Vadodara only, bus station. It has become viral actually. This looks so nice. People can't believe it's a bus station. And this is the mass housing happening everywhere in the country now. And this is the power plants. We have the irrigation dams. And in irrigation dams, byproduct is power generation also. And these are the underground tunnels in metro. And this is Bandra Worli ceiling bridge. And we have this wind power generation, wind turbines. We have the airports and highways happening everywhere in the country. Highways also involved with structures of grade separators and the bridges, and then airport air traffic control and all that. And the power, this is the most interesting structure, that is cooling towers in the power generation. So these are all the structures, types of structures we deal with. And what does a structural engineer do? What is the role of a structural engineer? We are slowly getting into the topic, that is the design intent. We understand the intent for the design. That means who are the end users and what are their requirements, we understand, and we prepare the design basis. And then we understand the standards to be followed, Indian standards or manuals also. We have sometime, if the code is not drafted still, if it is evolving technology, we prepare the manuals. Like I made an attempt in communication towers when there was a flurry of this implementation of towers. I didn't find the relevant standards, so I prepared a manual involving all the industry stakeholders, and that has become a basis for our work. Over a period, the manual gets converted into standard. So methods, this is another thing, methods of construction, methodologies of implementing each activity, and practice. The practice, there are certain things that are this is what you should know outside through internship, understand the practice. Next is, what are all the structural forces that we deal with? The compression, tension, shear, axial forces, bending and torsion, in-plane stress, in-plane strain. So these are all the forces that we should understand. I have just given the idea, this is from the textbook only, the shear force and bending moment. It's very interesting to understand these behaviors. So we are almost close to God. I always say structural engineer is close to God, except giving life, but everything else we do, we help the life in, and also we give the life to the structure. So vibration, damping, mode shapes, deformation control. So these are all the things we can play with the stiffness, we can play with the deformation, and we can also understand the mode shapes of the structure behavior. So we do testing, simulation, and we make the models, and we investigate the forces and stresses, how they behave under various tests. And in fact, I have even involved in prototype testing of towers. That's a common thing, but it will be an experience as a structural engineer to involve in this prototype testing. This is the model testing. And investigation of the loads, investigation of the soil, geotechnical, investigation of the topography and all that. Large spans we deal with and tall structures we deal with, they require this kind of testing. And robustness, structural robustness. Robustness means you remove one column and still the structure should be stable. That is the robustness we should check. And limit states. We know the limit state of collapse, limit state of serviceability, all these limit states we should understand for the behavior of understanding the behavior of the structure and the performance of the structure. Ultimately, we have to also know as a structural engineer about repair in case the materials don't meet the specified standards and the technical particular. Rehabilitation of the structure which is distressed in case sometime, restoration of the structure, and retrofitting. Retrofitting means, you know, every 5 years, 10 years, the codes keep changing, our requirements keep changing. Nowadays, people are talking about work from home. So the houses need to be retrofitted to accommodate work from home and family meetings online. So this is called retrofitting. Similarly, structures, when the codes change, we have to retrofit the structure to satisfy the revised codal provisions. So next is the pre-stressing, post-tensioning. This is another technology like pre-stressing of concrete, post-tensioning of the slabs and beams. So these are all the stressing techniques which will help efficiency of the structure. And the construction, we should know construction technologies available, fabrication methods, and erection methods. So how do we erect? Various experiences we get as structural engineer, and also understand the loads completely. Next is the acceptance criteria, tolerance in elements like column verticality or column orientation, column dimension, and slab levels before casting and after casting, after stripping. All this we should have the tolerance levels. We should know the code IS 12000. And the construction methods, exposure condition. This is where I have taken the worst picture. Actually, if you don't consider the exposure condition, like what is given in IS 456, mild exposure, moderate exposure, normal exposure, and severe exposure and extreme exposure condition. So we should know these structure elements are exposed and we have to give the proper treatment and enough cover. Fire rating is another thing. So we have to give the cover depending on fire rating, half an hour fire rating, 1 hour fire rating. So the structural element that can stay for fire rating. Next is the corrosion protection. You are seeing here corrosion due to the severe exposure condition, steams, fumes in the industry. And next is the water weatherproofing. Weatherproofing is to maintain the temperature of the structure element for reference temperature for which we design the structure. And periodic qualification. That is, any structure we design, we can't give guarantee for life. Like a child born, we do all the tests and we can't say this baby can live up to 100 years. No, we have to keep checking periodically. Same way, structures also every 5 years, it is recommended to have the periodic qualification of the structure for the loads designed, for the occupancy that it has, and all. So this is a wind tunnel photograph because it is interesting how this is a photograph of Burj Khalifa being tested for wind loads. And it's very interesting story. I will not go into the details. And this is a transmission tower, for example, how it is tested for its exposure condition, terrain category. So this is how the wind tunnel test when we do, we understand the behavior of structure and the loads, wind loads. So as a structural engineer, we should understand how the loading happens to the structure so that the shape of the structure, we can make it more efficient. So Burj Khalifa, that's what happened. And here you can see, once two structures come, the wind pattern has changed. So this is windward phase and this is the leeward phase, and you have the drag effect. Drag, this is called the drag effect of the wind. And when you have multiple structures, this is how you will see the wind pattern on the structures. So it's not in isolation. You cannot take wind coefficient for this one building and design the building. You should understand the various possible conditions and consider the worst case scenario for calculating the load. So the role of structural engineer is to first minimize the load effect on the structure. So this is what, just for the sake of interest, I've shown this. And now, what is the role of structural engineer? We understood the structure, we understood structural engineer, and now what is the role of a structural engineer? We have to suggest most efficient, optimum, and cost-effective structure, and understand the behavior, stress levels, and failure mechanism. It's very important. If you want to be a good structural engineer, you have to understand the failure mechanism. Then only you will be able to design and detail perfectly. And loads, 2D design, we have to estimate the loads and do 2D design. That means manually. Nowadays, people have forgotten this pencil calculation. You know why we call pencil calculation? You will be able to modify, improve the design. So never go onto the computer for analysis or drawing. As a structural engineer, you should draw with your hand, draw with the scale, and do the calculation with a calculator or even without a calculator. And you will. So the model. Can you put on mute, please? Somebody is disturbing me.
I request all the participants, please mute yourself.
Yeah. Otherwise, we lose time. So the pencil calculation, the model of the structure, how you model. You want to give a hinge to the support. You want to give a fixity to the support. The modeling, the structural elements, rigid joint, torsional rigidity, all this. And method of analysis, there are so many methods of analysis. Like, you know, ETAPS is different from STAD, and in SAP you have the master slave node options and all that. So we have to understand the methods of analysis and know the codes, manuals, and practice construction methods, analyze, design, check, detail, check again, and test. So this is the design process. After estimating the loads, after doing all this, we do the analysis. We visit during construction stages, check compliance and quality, and approve the shop drawings of the vendors, bar bending schedules, method statements, and technical specification. Conduct acceptance tests, and finally issue the stability certificate fit to occupy. Next is the as-built drawings after construction is done. Because during construction, there might be some changes. So we have to finally make the as-built drawing so that in future, if you want to verify, this will be the basis. Periodic inspection of quality control registers. Defect liability period, 1 year. Normally, nowadays with RERA, it is 5 years. Periodic renewal of stability certificate. So as a structural engineer, we should say, ask the end user to renew the stability certificate. And finally, repair, renovation, and retrofitting also is our role. Safe, serviceable, sustained structure, protect from natural man-made disasters, knowledge of material, methods, behavior, loads, systems, and technologies, and the standards, codes, proof check, peer review, testing of the loads, like pile load test we do, and plate load test we do. All these are required. Testing of the structures also. As per IS 456, we have the method of testing. In case of dispute about the force estimation or deflection control, we have to go for it is recommended to go for the test. No failure mechanism, detailed to prevent failure. Actually, detailing is to prevent failure, last resort actually. Design for serviceability and estimate the actual stresses to be within allowable or limit stresses. So this is the main job of the structural engineer. And then soil structure interaction, we should understand foundation design, slope stabilities. When we excavate deep or when we do the filling of earth, we should have the understanding of the slope stability, though it is a geotechnical job, but a structural engineer should have the basic understanding of all these things, because ultimately we have to take care of the slope stability also. Hydrostatic pressure, that is the underground structures, water retaining structures, and highly corrosive structures. Collective responsibility of a structural engineer is to plan, design, do the geotechnical investigation, proof checking, and supervision. So, planning engineer, design engineer, geotechnical engineer, proof checking engineer, supervision engineer. So 5 engineers should jointly take the responsibility for the stability and the performance of the structure. And quality plan and quality assurance, quality control, quality audit, and quality vigilance. These are the terminologies, and it's the role of structural engineer to ensure that all these are in place for important structures. Documentation, professional engineer, you have to be a professional, and you should maintain the updating your knowledge by becoming a member of professional bodies like ISTACI, CEFI, ACC, IEI, IAB, IRC. These are all the organizations where you can keep updating your knowledge. Thanks to internet now, you have YouTube channels and you can also get updated knowledge. But interacting with the professionals will always help. So continuing professional development. Every year, a structural engineer is expected to spend 50 hours in only learning and updating. Vendor updates, you should also know the latest vendors, products and technologies coming up. Detailed investigation like geology, geotechnical, hydrological, topographic, meteorology. Meteorology means rainfall, temperature, and all this. And environment. We should also have the understanding of the ecology of the surrounding places, like forests, lakes, rivers, seashores, and all. So, and also we should have the understanding of the earthquake, cyclone, and fire, blast, and flood, and construction practices. So this is the role of structural engineer. Now let us get into the examples. Like structural engineer role is design life. So this is a beautiful structure. So it's already more than 200 years old. You can see no distress or no dampness or no mar. So this is the ideal structure we have to design as a structural engineer. And we should have the design performance studies by isolating and all that. And then this I explained already: design intent, design basis, inception report, coordination, investigation, budget, time, cost, construction technology, design life. Service life design is emerging new specialization actually. So we should also, and also we should have the idea about the, so this is a investigation, topographic survey. Normally you end up surveying up to the boundary, but you should also go beyond the boundary, understand what are the surrounding structures also. Next is the coordination with air conditioning, electrical, plumbing, and firefighting. So this is a coordinated drawing with the structure ultimately. So the structural drawing that we make should accommodate all the services that are there in the building. And geology, carbon footprint, this is sustainability concept. And loads, we deal with vertical loads, lateral loads, and temperature, and dynamic loads sometimes, and preliminary analysis and member sizes, and general arrangement drawings, analysis, modeling with geometry, and the results, stress contours, bending moment, shear force diagrams. You should compulsorily, once you analyze, you should study the results of analysis. This is called post-processing. So this is the stress study, how the stress is varying in the structure. As a structural engineer, we should understand the stress pattern in the structure. And these are the accelerograms for wind or earthquake, and we design for this from the accelerogram. Design for stresses, detailing, and check bar bending schedule. Check construction engineering, that means how it is going to be constructed, and loads during construction, and define construction methods and specification control, and periodic visits during construction to check compliance of the drawing, as-built drawing. Please don't think I am repeating, because these are all important. I am telling again and again. This is the construction method. For example, just for casting the what you call sajja here, sunshade. how much of construction engineering you see is taking support on the wall, and this is the bracing for these brackets and all that. So you should have the complete understanding of the construction engineering. And then finally, structural engineering is a challenging career, and you are satisfied seeing the outcome of the structures that we design. And it is the ultimate happiness, I always say, as a structural engineer, if you are a good structural engineer, and perfection in design. And we in fact, in the world, anybody is expected to be most perfect, it is a structural engineer. Everybody will ask why you have provided more steel, and if it is deflecting or if there is a crack, why you have not prevented this. Everything, they expect heavens from the structural engineer actually, and we create these heavens actually. So that's a satisfaction that we have. And fast track projects is order of the day, and we give life to the structure. And you all know healthy structure saves healthy lives. So we are seeing if so many people are not affected, means it is because of the structural engineering practices they're able to design. So 3D model structural system here, I'm just clearly showing shear wall and central core and a frame structure taking the support. This is called a buttressed core actually. So shear wall is buttressing the core here. So this is about structural engineering, and I'll deal with development, infrastructure development. So this is a tall structure we have designed in Hyderabad, residential tower, very economically and very efficiently, and aesthetic also. And this is the mass housing which we have done with the 3 technologies, that is precast and shear wall, rigid monolithic construction, or MY1 as popularly known. Sorry. And conventional with column beam slab system. So this is about 4,000 houses completed in 12 months at a cost of 1,280 rupees. That is a challenge. We have delivered 2 stills plus 9. And last 4 towers we completed in 4 months time. So that is the power of technology. So this is as part of risk mitigation, we have deployed 3 technologies in the same project. And this is a project which we have completed in 30 months. This is the 3D view, and this is the actual photograph. Actually 29 months. This is the realization. So that is the how close you are to the thing is the important thing. And this is a metro rail in Gurgaon. We have done the rapid metro rail Gurgaon here. So this is the 6 stations we have designed. And this is when you go to Gurgaon, we can see this. We have used the precasting in the thing. So these are the actual photographs of that stations. And this is also, you can see the precast girders here. And this is the drone view of the station, which is designed. And Chennai Metro also, we did the pre-bid design for one of the contractors. And this is the Rotary management system, it is called. That means you know the Rotary, you know grade separation. Here, these 2 are combined. You have the 3 grades, that is below ground, ground, and above ground. Above ground is used for heavy motor vehicles, and ground level is used for pedestrians, 2-wheelers, and auto, rickshaw, and all. And below ground is used for light motor vehicles like cars. So this is the design we have done in Vizag, completed recently, and this is the Google view of that. So you have, this is useful where you have 2 national highways intersecting in urban scenario. So this is the Google photo of the, so you can see this is one national highway, and this is another national highway, and there is an existing rail over bridge already, and still we have designed 2 limbs for this, and this is the Rotary above, and below it is nearing completion now. So this is the interesting infrastructure development we did, and these are the photographs of the structure. We have used the precast pre-stressed eye girders, and this is the deck being cast with the temporary shuttering. And so this is the girders erected, and this is bearings and all. This is another trumpet interchange in one of the airports where there was a distress in the RE walls, which we have restored actually. So we all take it for granted. Once this is done, it will perform. In fact, in this case, there was a distress in this RE wall, and there was a problem, and we had to rehabilitate this RE wall, and we have done it. And this is a hangar, interesting 45-meter span in a 13,000 feet above mean sea level, and the temperature ranging from minus 30 degrees to plus 20 degrees. And these are the door, automatic closing door, 30 meters length, 30-meter wide road, 100 feet wide door actually. So sliding door, and the height is more than 10 meters. This is 10 meters door. So it's an interesting structure we have done pre-installed. And this is a recreation club, boulder stitching. So we wanted to this rock garden. This is called rock garden. So we didn't want to disturb the natural rock. So we use the rock as the foundation. You don't see the foundation here, is it not? Just we have put the anchors onto the rock, and we stitched these boulders, and it's interesting. And this is all steel structure made to look like elevation elements. And so this is a truss kind of structure, and this is the farther view, clubhouse of a housing society. So we have done, and this is a sports stadium with a cable support. We have done. This is 12-meter span sports stadium in Nalsar University, and this is a 100+ meters. In fact, the tallest structure I have designed is 213 meters tall, and this is a FM tower in Barmer in Rajasthan. So this is very interesting structures, and these are the 90-meter communication towers in Gujarat also. We have done the Birla AT&T and Ericsson, Airtel, all these people, we have done these tower designs. So this is a 90-meter tall tower, and in Gujarat we designed 80 meters and 90 meters tall towers also. These are the monopoles. You can see 40-meter concrete, spun concrete monopole pre-stressed. It can be erected in 2 days, and it's a very interesting. We have developed this design with the concrete 40 meters monopole, high lighting mass, and precast piles also. This can be utilized. And this is a transmission towers. This is a live prototype being tested actually. You can see the cables will be pulled and tested. Very interesting thing. And elevated storage. This is the actual thing, and we model the structure like this, and this is a funnel type elevated storage reservoirs. And this is a detailed drawing of the elevated storage reservoir. And these are the effluent treatment plants in Tamil Nadu. 7 districts we have done designed for this very highly corrosive effluent treatment plant. And this is my first project as a consultant, and this is a jetty into the sea, 70 meters into the sea, seawater intake jetty it is called. And from here it is 1.2 kilometers aqueduct, and then we have a box girder crossing canal. This is the canal, and then reservoir intake structure, and this is the reservoir of 6 lakh cubic meter. So this is a very interesting designs we have done as structural engineer. And these are the photographs. This is the reservoir intake, and this is the aqueduct and distribution channel. This is the distribution channel after completion. So these are all the, and these are the Almaty Dam aqueduct, and this is the foundation for road bridge being done. And these are the interesting runways we have done. So before construction, we use the Google Maps and plan the boundaries and levels like this. And after construction, this is the photograph. And this is along another location, and this is after construction photograph. From the aircraft, this picture is taken. And this is another location, Kuting on the Chinese border we have designed, and this is the photograph from the landing. Actually, this is photographs are sent by my client who are landing on this runway. We have done the infrastructure facilities, and design of these structures is very interesting. And this is another Mechuka location, again 8,000 feet above mean sea level. And this is the actual photograph of the flyover, the runway. This is another location, Jairo in Arunachal Pradesh, and this is Walang, again Myanmar border. So this is the runway we have designed. and Dindigal also in Hyderabad we did. And then cross drainage works for irrigation canals. You can see these. River means there is an existing and we connect two sides of the river with a bridge. When canal is planned, we are separating land mass into two pieces. So we have to connect. So we designed about 18 cross drainage works for a canal in Polavaram irrigation project. And these are the expressway, toll gates design and elevated expressway design. And Amravati new capital, we reviewed the master plan, the road network and design. And Pradhan Mantri Gram Sadak Yojana, the village connectivity in all over India is a mass project happening, and we had the opportunity to work on these roads. And these are the bridges on small streams and rivers. And we had designed this causeway, it is called. That means causeway, difference between a bridge and causeway is bridge has to be above the highest flood level and causeway can be submerged in the water. And this is a bridge on riverfront. And then auto cluster, industrial clusters, we did the infrastructure, roads, water supply, and testing facilities. This is the housing, large scale housing we did. This is a Google view of housing project we did in about 600 acres. And this is a rehabilitation and relocation of Nuclear Power Corporation. We did the township design with all the structures and all. So now role of structural engineer back, obligatory spans for function and efficiency. We have to decide the optimum spans, optimum structural systems, and the geotechnical investigation. We have to engage a responsible agency and insist on proper report of geotechnical investigation. Topographic survey by agency with standards. Concrete mix design. Also, we have to insist on proper mix design. And supervision by qualified, experienced engineer in charge with similar projects involvement. Slab levels record, quality records, surrounding structures monitoring and surveillance, and the calibration of batching plants and third-party checks. And verticality, orientation, eccentricity, dimension, thickness, planes, level. These are the key words a structural engineer should keep in mind always and keep monitoring the structural work being done. And foundation soil bearing test, pile load test, plate load test and all, and structure loading test, vibration test, and 100 scale drawing of framing. And so you must get used to preparing the drawing yourself with hand, actually, never depending on only AutoCAD, because as a structural engineer, you get the feeling or understanding of the structure only when you draw with your hand. And water barrier, weatherproof exposure condition, ductility, liquefaction. Visualize the structure, loads calculation, structure idealization, preliminary member sizing, materials, geometry, loads, boundaries, model, analysis and results. Check the design, check the results, and check the design and detailing, and ensure the specification issued with construction methods and structure coordination with services and facade finishes. So this is a typical stability certificate to be issued by a structural engineer. This is given in the National Building Code. So we are responsible for the stability of the structure. And we have to have ethics in our profession to maintain uniform standards, to respect fellow professionals, to avoid unhealthy competition, to maintain dignity of profession with other professions, and to use the materials optimally and as demanded by the structure, to maintain professionalism with vendors, challenges in profession, public trust, employability of engineers, ethics, SOP, standard operating process, and the registration of structural engineers in every urban local bodies, and recognition of engineers is a challenge. So encourage innovation in affordable housing, healthcare, urban infrastructure, transportation, flood management, and manufacturing. So train engineers, motivate engineers to be engineers, enlighten developers and builders to engage engineers, nurtured engineering gets better engineers, and buildings get distressed without building engineers or building engineers. And no causes or remedies for projects with good engineers. So let us all be good engineers. With this, my favorite slide, I conclude my talk and thank Pandit Deen Dayal Energy University for giving me this opportunity. And any one of you having any questions, you can ask me now, or you can mail me, or WhatsApp me, or Telegram, or Facebook SmartInfr-EST, and LinkedIn Surya Prakash Ponnada. These are my connectivities, so you can always connect with me for any doubts in future. Thank you.
Thank you, sir.
Yeah, I'll close the sharing.
Yes, sir.
Or you can remove the, I don't know why I'm not getting.
Okay, sir, fine. No issue.
Yeah, now it's okay.
If students have any students having any doubt, please ask. Otherwise, first I want to thank you, sir, for explaining the what is structure, what is the structural engineering and role of structural engineers in infrastructure development. Thank you for explaining to our students. So if any students is having any doubt, then floor is open.